RT1-4, I can use the Pythagorean theorem. So we'll be talking all about the Pythagorean theorem today. In a right triangle, the hypotenuse is across from the right angle, so it's there. It's opposite the right angle. It also ends up being the longest side of the right triangle. This is not true of all triangles, just right triangles. What the Pythagorean theorem says is in a right triangle, so again, this only works with our right triangles. We have to have that 90-degree angle with legs A and B. We'll call the legs A here and B here. Notice they connect at that right angle. And then we have the hypotenuse, which we'll call C. We learned that's opposite our right angle. The sum of the squares of each leg equals the square of the hypotenuse. In other words, A squared plus B squared equals C squared. Here are some proofs and facts about Pythagoras of Samos. You can pause and watch these or watch them later. There is also a Desmos proof in Schoology. You can click on that link and watch how and why the Pythagorean theorem works. All right, so let's look at some examples. Example number 1, we're going to find the missing hypotenuse. Now, I do need to draw this in. It is a right triangle. Google wouldn't let me draw that in there. So trust me, these are right triangles. We're going to find the missing hypotenuse. I'm going to label it C. So we're going to start with A squared plus B squared equals C squared. We know that the legs are A and B. It doesn't matter which leg you call A and which one you call B. Maybe I'll call this one A and I'll call this one B. And we're going to substitute it into our formula. So 3 squared plus 4 squared equals C squared. 3 squared is 9 plus 4 squared is 16 equals C squared. 9 plus 16 is 25. 25 equals C squared. Now we need to take the square root of both sides, so we get C equals 5 centimeters. All right, let's look at example number 2. In this one, it says find the missing leg. And again, we do know that this is a right angle. That's very important. We'll call our missing leg B. I could call it A or B. We'll call 5A. And then let's remember that our hypotenuse is always C, and the hypotenuse is always across from the right angle. So we have A squared plus B squared equals C squared. 5 squared plus B squared equals 13 squared. 5 squared is 25 plus B squared we don't know equals 13 squared is 169. Now we need to use our algebra skills to solve for B. So minus 25 on both sides. I'm going to move my work up here. B squared equals 144. To get B, we need to square root both sides. B equals 12 centimeters. Okay, now let's look at our last example here. Find the length of the red line. Notice we have a circle and then we have a red line. As you look at this and you're thinking about the circle, you're like, I don't know, there's nothing we can do. And you are right if we just had the circle, but we're given a line and we can actually draw in our right angle. Okay, and we can make that triangle, make that a right triangle. And we know that this point here is at 6, 8. 6 is our x value, 8 is our y value. Notice that a coordinate plane was really kind of drawn on here for us, which is nice because that helps us to see that our x would be this length here. So I can label that 6. And our y would be this length here. So we can label that 8. Now we have enough information to solve. A squared plus B squared equals C squared. I'm going to call 6A and 8B, and our hypotenuse is always C. So we have 6 squared plus 8 squared equals C squared. 6 squared is 36 plus 8 squared is 64 equals C squared. 36 plus 64 is 100 equals C squared. Now we're going to square root both sides, which tells us that C is 10. All right, let's look at another example. The diagonal of a square measures 50 inches. What is the area of the square? So we're trying to find area. That's going to be very important. In this, we want to draw a picture. Remember, with a square, all of the side lengths are exactly the same measurement. This problem tells us that the diagonal here is 50. That's going to be very helpful. We also know with a square that we have these right angles. So we can see here that I have a right triangle. We're going to go ahead and find the length of the side, and we're just going to call each side A because they're exactly the same measurement. And we're going to call both those legs A instead of A and B since they are exactly the same measurement. So we can then say A squared plus A squared equals 50 squared. And we're going to solve for A squared. A and A, there's really a 1 in front of them, so we can combine those to get 2A squared equals 50 squared is 2,500. Divide both sides by 2. We get A squared equals 1,250. Now, many of you are going to want to take the square root of both sides because that's what we've been doing. But let's remember we want to find our area, which is length times width, or in this case, A times A, which is the same thing as A squared. So the area equals A squared. We found A squared, so we can leave it like that. 1,250 is our answer. Now, if you did go ahead and take the square root, you would just have to then square it again to find the area. All right, let's look at another problem. The area of the square is 81 inches squared. What is the length of the diagonal of the square? So this is similar to our last problem, but we're actually going to work in the opposite direction. So again, we have a square. Okay, we have our right angle here. We need to find the diagonal. We know in our square that all the sides are exactly the same. And if the area is 81, that means that our side length, or A if we call it, is 9, because 9 times 9 is 81. Now we need to find our diagonal. Okay, so to do that, we're going to use the Pythagorean Theorem. A squared plus B squared equals C squared. And again, A and B, we'll just call them A. They're the same. So it's 9 squared plus 9 squared equals C squared. We just need to solve. So 81 plus 81 equals C squared. 81 plus 81 is 162 equals C squared. We need to take the square root of both sides. So we can leave this as the square root of 162 to equal C. If you remember from algebra last year, you did learn how to simplify radicals. We have not reviewed that yet. We will coming up here soon. But I'm just going to take a moment to briefly review that for you over here. So if we have the square root of 162, we want to break it up. And we can break it up into 81 times 2. Okay, we're going to be looking for perfect squares. So if I look at 81, I know that 81 is a perfect square, and that's why I chose to have it be 81 times 2, because then I can break it up into the square root of 81 times the square root of 2. The square root of 81 is 9. The square root of 2 just stays, because we can't simplify it any further. If this is still a little bit challenging, no worries. We will have a lesson coming up just on radicals. All right, how far is the throw from home to second? So that's Pythagoras here playing baseball, and we want to figure out how far the throw is from home to second. So let's recall, or let's know that a baseball diamond is a square, and we are going to use the right triangle along here to find that information. It says 90 feet there, so that means this is also 90 feet. Okay, and we're looking for C. So A squared plus B squared equals C squared because we have a right angle. 90 squared plus 90 squared equals C squared. 90 squared is 8,100 plus 8,100 equals C squared. Add those together, we get 16,200 equals C squared. Again, at this point, we're going to square root, and I am okay if you leave your answer as the square root of 16,200. Coming up shortly in a few lessons, that will not be okay, but for now, that is okay. To simplify, let me just show you how you could simplify. So we can break up 16,200 into 8,100 times 2, We knew that from before. And then we know that 8,100, the square root of that is actually 90. So we can do 90 times the square root of 2, which is equal to C. I will accept either of these two answers. Go ahead and rewatch as needed. Otherwise, you may start on your practice. The next few slides are blank space for you to show your work.